Hello, my name is Igor and welcome to my Tech One. Approximately a year ago I was experimenting or engraving stainless steel using a mustard on the surface, and I got quite interesting results. It was exactly this knife and I can still see that engraving. It's a little bit light, but it's still there. But what is more important, I got a lot of several useful comments, and one of them was to test the Brilliance Laser Inks. And I checked their website and I saw they recommended to use it with the CO10 fiber lasers. And then I saw on their official YouTube channel the user manual information how to use this black metal laser spray. And I saw the comment that somebody asked if it can be used with the diode laser modules, and their answer was that they didn't test it with the diode laser modules, they don't use them. So I contacted them and I offered that I could test it with the diode laser modules because I have several of them, because nowadays these diode laser modules became quite strong. If I have a good focusing, I could engrave directly stainless steel with 5W laser modules, and almost every 10W laser modules can do the engraving on the stainless steel even without using the black marker on the surface. And they sent me this scan, and on it says it used with CO2 fiber and YAG lasers. I don't even know what are the YAG lasers, but I have a lot of diode lasers, as I mentioned, and I will test it with 4 different materials, and I will start using it with 5W diode lasers, and if necessary I move it to the 10W laser module power. And I will test it with different materials. One of them will be the stainless steel, but I also have these metallic rods, aluminum, brass and copper, and I cut them to smaller discs. And then I turned them on a lathe machine and created this smaller disc. I want to try to create some kind of coins, if this will work. Now, just to be clear with the possibility of diode laser modules, this is with Orthor Aufera 2 short focus and long focus 5W diode laser module. This is with Atomstack 10W using directly on the stainless steel, and this is the same module using a black marker on the surface. And this is the TTS55 2-3 laser module, 5W power, and I think I use here the black marker. This is the Comgrow 10W laser module, and this is the new 2-3 laser module 10W TS2. And actually I can feel that the stainless steel is melted with this. I will start using the TTS55 laser engraver, which has the 5W laser module, and with this directly on the stainless steel it could left this mark here. I'm starting with the cleaning of the surface with some isopropyl alcohol, and I will engrave here on the top side of this plate. I have 2 nozzles here with this bottle. Next step is the shaking the can for at least 2 minutes. And then spray to the surface from approximately 20 centimeters distance. That's approximately the size of this can. Now I have to wait until it dries completely, or I can use some hair dryer to speed it up. I will not place this back, it will be better visible, and I will set the focus, but I don't want to touch this surface, so I will try to set the focus on this side. And in Laser GRBL I'm opening a file. This is image 5 by 5 mm square, and I'm using the line-to-line tracing, 12 lines per millimeter. And I will start with 100 mm per minute speed, M3 constant power, and of course 1000, which is 100 full power. 5 by 5 mm square, create. Safety glasses on, boundary check, and starting the engraving. This was finished in approximately 3 minutes. Now I will double the speed, so 200 mm per minute next to it, and engraving. So this was finished in 1.5 minutes, and I am doubling the speed again. The next one will be on 400 mm per minute. 800, 1600. And it's time to clean it and to analyze the results. And basically on each speed they are very black, and let's see This will come down very easily, so pay attention not to touch it before you finish the engraving. Interesting is there. Let's try to remove it with isopropyl alcohol, but this should be permanent marking. And to be honest, so this was on 100 millimeters per minute, 200, 400, 800 and 1600, and basically this is the darkest. So marking is here, but as you can see, I have much better effect. It is a full filled color instead of these thin lines. So I will create this kind of logo, but with the black color on this knife. Be careful, I can see even the boundary check left some minimal marks on it. I hope they are not visible on the stainless steel. And now let's start with engraving. And here it is, very nice, visible and looks like durable marking, but I cannot really test how permanent is this, since I will publish this video in 2 days from today, and I cannot change the content of the video, but I can change the description. So if there will be any significant changes, please check the description of the video, because I will add those informations there. And it's time to move to aluminum, and before I start with this coin engraving, I want to experiment a little bit on this aluminum. And I will start with the stainless steel settings, so it will be the maximal power of 5-watt laser engraver with 1600 millimeters per minute speed. 5 by 5 millimeters square, 1600 millimeters per minute, full power. It is not so strong as like on stainless steel, so I create 2 more squares on the lower speeds. And 100 millimeters per minute, full power. So it's cleaned down, and unfortunately the strongest is on the 100 millimeters per minute, so the slowest one. And I will now try to use these settings to create some kind of coin, but this will be very slow engraving. According to the laser GRBL, this will be 45 minutes engraving only for one side of this coin. Well, boundary check. And let's start. It looks like the disc is not correctly centered on the design, but I will leave it as it is now to be finished, because this is extremely slow engraving. And unfortunately it looks like on aluminum it is not so permanent marking, so I think I will stop with the experimenting. Maybe I will do some tests with the 10-watt laser, but this diode laser is too weak for this kind of engraving. And it's time to start testing with the brass, but before I do some engraving on this disc, first I will need some experimenting on this piece of brass. And I will do full experimenting, so I will start from 100 millimeters per minute, 2, 4, 8 and 1600. From left to right. Unfortunately it looks like it is not too permanent, because I can see some black marking on this textile. Basically very similar contrast, so probably I will try with this one in the middle on 400 millimeters per minute. Anyway, let's try one attempt on this disc. If I will have some black marking on this textile towel. No. So this means it is more permanent. Interesting. So yes, it looks like on the brass it is better than on aluminum. But the other side I will do with the 10-watt laser engraver. and it's coming down a little bit, so I can see here. It's not so easy to scratch it down, but it's not so permanent. And now copper, and I have one failed disc, so I will experiment on this one. Boundary check, and I'm starting with 100 mm per minute full power. 200 mm per minute, 400, 800, 1600. No, it's not staying on the copper. Atomstack with 10W laser module. And I'm starting with the stainless steel, but I will create a smaller square so I know that which one is with the 10W laser module. And I will start with 800 mm per minute and 1600, and maybe one more I will see later. The problem I have now is that I don't see exactly where will be the laser beam during the boundary check. 800 mm per minute, 1600, 3000 mm per minute. And each is in a perfect color and they are not coming down at all. And now aluminum under 10W laser module, and I will engrave here smaller squares, and let's see if we get a better markings than these. 100 mm per minute, so the slowest speed I tested these engravings. And this is second engraving on 200 mm per minute. Definitely more permanent than on the 5W. The tower test. And it's clean. So this is much more promising. I cannot scratch it down. So definitely 10W laser module is much better for this compared to the 5W. It's coming down now. Unfortunately not so permanent, I could scratch it a little bit. And it's coming down. And I know that this is not the permanent solution for the aluminum coin, but I decided to finish the nose side too, engraved on 100 mm per minute. The tower test. And it's dirty. So it's coming down. And now the brass with 10W, so this was engraved with the 5W, and it's coming down a little bit, so I can see here. I have to remove the glass because I cannot see the boundary check, the position of the laser. Starting with 100 mm per minute, 200 mm per minute, 400, 800. Looks very dark for the first look. The tower test. And it's clean. For the first look it looks permanent, but I can see coloring on my finger. Interesting, they are very similar on each speed. And this is with 5W. 100, 200, 400 and 800. So this was with 5W laser, not so permanent, and I will do here the nose side. The tower test, and it's clean, so it's not coming down so easily. And now the nail test. It's not coming down. Unlike the other side with 5 watts. And the last test, the copper. As you can see, I could completely clean the previous one, the engraving with 5 watt. So I think one test, but I don't think this will work. Starting with 100 millimeters per minute on the top. 200, 400, 800. Looking good so far. Now it's dirty. My finger is dirty, but I cannot see that it is coming down, but probably it does because it colored my finger. But interesting that the equal color I have with all 4 speeds. I know this is not permanent solution, but I will create this coin anyway. So it looks very strong, but as you can see it's not permanent, it colored my skin. So for example, if you left this coin in your pocket, it will color your pants or something like that. But otherwise it would be a great coin. And one last experiment for the end. I want to see can I engrave a regular steel. So I have this 8.8 bolt. Basically this is the marking for the strength, but this is not stainless steel. Otherwise it would have marking 8 or something like that. Now some of them might be nickel plated, so I cut the end and I clean it on the lathe machine. I will try to engrave here those small squares. I'm starting with 100 millimeters per minute on the top, and in the line below there are 2, 4 and 800 millimeters speeds, and the last one 1600. And interesting, the fastest is again the darkest. And the tower test, I hope my wife is not watching this video. And it's clean. And now the finger test, this one is still clean. And it's still clean. And interesting is to see that the speed don't have any effect on the quality with this marking. Now let's see what can we see under the microscope, and I will try to scratch it with this kitchen knife. This is stainless steel, and I really press this knife so to make these scratches, but absolutely no signs of the wearing on the black color. And this is brass. First I started with a light scratching, and then I press it hard, and only then I can see some removing of the black color. And this is aluminum, and only light stretching already removed this black marking. And similar on the copper. Just a light scratches and the black color is removed. And this is that regular steel, and here I can see it is not so perfect like the stainless steel, but this marking is very durable. But keep in mind that these 3 materials are much softer than the steel, especially the aluminum, and maybe I actually scratched the material itself and not the marking. And now the conclusions. Well, with 5 watt diode lasers I could get good results only with the stainless steel, and this marking is still very dark after 2 days, and this knife even survived one cleaning in the dishwashing machine. The second is the brass, but I couldn't get permanent results with other same materials. Now with 10 watt diode laser the story is completely different, much better, surprisingly better. I was expecting a smaller difference. Of course, great results with the stainless steel and even with the regular steel. The brass looks like we can get almost permanent marking on the brass too. On sample during the testing, one which is printed on the fastest left some mark when I tried to scratch mark on my nails. But when I printed this coin on 400 millimeters per minute, this is still there, and I cannot see any signs of wearing of this masking. This means it is very close to be extremely permanent, so probably much better results I will get with 20 watt lasers. Now aluminum and copper. For the first look, very dark and durable engravings. But when I try to scratch it, I cannot see any damaging on the masking so far. I try continuously these 2 days, but I can see that it colors my finger when I try to scratch it on my nail. So this means those are first signs of the wearing of this masking. So it would be very interesting if I would try this with 20 watt laser engravers. I think I will get one soon for the testing. I hope I will still have something in this can for repeating these experiments with the 20 watt laser engravers. But if you are using these Brilliance Laser Inks with the diode lasers, please share your experience down in the comment section. And also keep in mind that this is only 2-day testing. I give my best to see if it is permanent or how durable is this marking. And of course you will get different results with the different types of the lasers. Well, I try to share my experience. Thank you for watching and happy and safe engraving.